Cecence was founded just under 8 years ago on the Wiltshire-Hampshire border. We have a very innovative and agile approach to the manufacture and development of lightweight FST components. We're very proud of our largely locally based team, our sustainable manufacturing processes, and our RMRA, right material, right application philosophy, which enables us to select the optimal fibre and resin combination for each application. The award we've been nominated for is the result of a NATEP project where we developed an affordable, ultra-thin, lightweight, sustainable aerospace interior seat bag. It's maybe useful to talk briefly about the landscape within which this innovation sits in order to reinforce the need for the approach we've taken on this structural component and continue to take with the development of our other new products. COVID-19 continues to economically damage the travel sector. Consumer pressure is being put on airlines by passengers who are better educated about climate change, and the Swedish even have created a new word, flickskam, to describe flight shaming. There's a real need and opportunity for airlines to demonstrate their commitment to the environment. And at the same time, the UK government's ambition to achieve net zero carbon emissions by 2050 has succeeded in reinvigorating the idea of a circular economy. And in the manufacturing sector, there has been a renewed interest in the use of sustainable materials and sustainable production methods. Consumer pressure will inevitably push for new eco-friendly materials to be introduced. The growth in recycled and renewable lifestyle products, a move away from fast fashion, and an increase in electric car ownership would suggest this to be the most likely direction of travel. To meet the environmental demands for future air travel, we'll need to look for lighter, recyclable components aligned with alternative fuel systems. Much development in greening the aerospace sector has focused to date on the development of alternative biofuels and the recycling of in-flight consumables. Our focus is on lightweighting the cabin using carbon and glass fibre to save on fuel burn. While structural and semi-structural aerospace lightweight carbon and glass fibre composite components have started to be embraced by the aerospace industry, they're still largely reliant on phenolic resin systems. By integrating BioResin for future aerospace interior products, we can reduce the carbon footprint of the aircraft's fuel burn and encourage much-needed investment in, ideally, a homegrown supply of sustainable resin systems. Traditionally, phenolic systems have not had the structural strength of epoxy systems. For the development of the ultra-thin seat, Cecence integrated carbon fibre with a bioresin and achieved both clear FST compliance and strength. Early use of non-destructive testing was an integral part of the development process, allowing optimal materials to be selected at a very early stage. And the basis of this research, combined with Cecence's composite material, structural engineering and processing know-how, is at the heart of this innovation. Cecence were awarded support through NATEP in the form of 50% of the development costs for a project entitled Lowcost FST compliant composite components. The 18-month project was completed in early 2020 and initially set out to develop a relatively small structural subcomponent of an existing seat design. As the project developed, and through our partnership with SHD Composite Materials, Wavelength NDT, and later in the process Pliable, we could see the potential to not simply focus on the originally selected subcomponent, but to look at how we might take the early analysis and study and apply it to a whole seat back. This in turn provided the encouragement for Design Q to work closely with Cecence on the development of an entirely new, larger structure, excited by the discoveries made during the project and a greater understanding of how carbon fibre and bioresins could provide both a radical weight saving and a sustainable design. Cecence's practical approach and understanding of how to industrialise composite production through its proprietary preform and processing methods produced a seat back that was slender, incredibly light, strong and sustainable. The component is further designed to be compatible with an existing seat frame structure, helping to drive down costs for the airline in terms of upgrades to current seating. The innovation enables more legroom and fits with the needs of today's commercial airline passenger. The 7 kilogram weight of the design saves at least 500 kilograms per flight on an A320. The seatback's bioresin carbon composite offers an opportunity for the airline to demonstrate its eco-credentials to today's eco-savvy customer and to support a circular economy. The resulting product is a great example of driving innovation through a collaborative approach.